Now we'll start with the ObjectiveC properties. So ObjectiveC, what is properties? Now if you see the interface, what we declared, vehicle. So let's copy the interface block. So I'm just copying the interface block. I will increase the font size by 24. Now also we've declared few methods, right? So let's take those methods into consideration in the declaration. Obviously I've decided to be instance method. Okay, so this was a typical interface block we had. Now in your .m you would have, so in other language you call model number as a member variable to the class, or the property to the class, or the attribute to the class, and you you can write such type of statement, right? Int v1 dot model number equal to 5, you can say v1 dot, or you can write int a equal to, so in first line the dot operator acts as the setter, in the second line the dot operator acts as the getter. Now if you see the programming language, 95% of the time you will be getting some values of some member variables using a dot operator. You will be manipulating and setting some values to some other member variable using a dot operator. So it's always dot operator. The getters and setters, if you write getters and setters, so much line of code is increased. So dot operator helps you to avoid getters and setters. But suppose you have an application which has 2000 variable declared, no matter whether you wanted or you didn't want, 4000 getters and setters were created. So that means 4000 member functions are available in your memory, right? Now that is avoided by the ObjectiveC. In ObjectiveC they say when you declare variable, they are member variable. You cannot use dot operator on member variable because getters and setters are not created by default. If you want to create getters and setters by default, you declare them as a property. So I'll declare one more variable like double price of the vehicle. Now outside the curly braces I will declare them as a property because they are getters and setters, accessible. So in order to tell the compiler, we say @property. There is something called attribute list, which we'll see after we complete the property concept. And then you want to say int model number. Then only dot operator is allowed. Similarly, I decided that I want NSString name also as to be a property. So I'll declare them as also. So dot operator will be applicable on the name and on the model number, but not on the price. If you try to use dot operator on the price, you will get sigbarred or say no, function not found exception on the runtime, because the function pointer for price is not created. Function pointer like get price and set price is not created. But if you see, you are redeclaring the same thing. Redundancy of code is there. Prior to Xcode 4.2, we used to do this way. But after that, if you declare the variable as a property, you don't need to declare them as a member variable. It's understood by the system they are member variable. Now attributes tell how getters and setters needs to be created by the system. So in ObjectiveC, member variables are different, properties are different, and attributes are different. They are all three segregated. Now what we're going to learn today in property is nothing new you are learning, but you will see how ObjectiveC make it streamlined. It's more important. Now this is the way you can access it, right? Now in .m, initially by default it shows @dynamic. If you don't write anything, now this property is a declaration. Its implementation in .m is @dynamic model number, comma name. So if you don't mention it, by default compiler will write this way, and it will expect you to write getters and setters declaration on your own. 99% of time when you declare a property, you do not want to write getters and setters. Therefore you are declaring as a property, right? So that you can directly use the dot operator, but that 99% is non-default. So you have to explicitly write @synthesize in your vehicle.m. Now in Xcode 4.6 last year recently, and in Xcode at the application level of Xcode, they have made synthesize as a default. So if you don't mention anything, it will write @synthesize at the application layer. The changes have not made in the ObjectiveC layer, because if they make changes, then they have to change a lot of things, right? So we normally don't write synthesize nowadays. Now, which is that 1% where you want to create your own getters and setters. It's called dependent property. When your property, some properties are dependent on some other property. Like in a case of person, age and born date. So if someone set the born date, age needs to be set automatically by comparing the current date and the born date. So in that case, we override the setter of the born date so that we can set the getter value of the age. So this is how we use setters and getters. Okay. Similarly, the reverse way is also possible. If you set the age, the born date needs to get initialized properly. So only that 1% of the case where we say dependent properties are there, that time dynamic makes sense. But in Objective-C, it was reverse. So now in Xcode 4.6 and above, like 1 year, hardly 1 year before, at the Xcode application layer, they have made synthesize as a default. So if you didn't have a synthesize as a default, how are you gonna create the getters and setters? Obviously, getters and setters are instance level. So in other language, you have get and the name of the variable. Here, it's directly variable, and then you say return model number or any integer value. For setter, you have minus, return type void, set with set. The first variable is capital, colon, the type of the variable is a pi, and then you can have any variable, and you can say model number equal to. Now this is the way getters and setters are created. Now the most important part of property, now property looks very simple, and I was saying memory management and all these things. Okay, it has a better significance than the other language. You can control the creation of getters and setters at your own hand. So suppose some variables needs to be instance variable only, IVAR, you will declare them in a curly braces, and some variable you will just create as a property because you want them to be accessed using dot operator outside your class. Okay, now the memory management happen with the attribute list. There are various set of attributes, so you're going to understand the attribute list, which is the most important part of this course. Okay, at the first set of list is read write or read only. Now out of these two values, you have to select one of here. So if you don't select anything, read write is default. That means getters and setters will get created. If you say read only out here, then only getter gets created. No setter will be created in your application only. Now same thing is allowed in other languages also, but then you have to override the setter, make it private and all those things. Round and round things happening. Here it's straightforward. The second set of attribute, now this is what is straightforward, is assign, retain, copy. Now this is for Objective-C objects, okay, only, where the ID concept comes in. Now assign means is by default. If you don't mention, it's assign. Okay, now let's see the setter of the name. If you say assign, then your setter will be something like this. That means whatever reference is coming as a parameter, it will assign. It's a shallow copy without incrementing the retain count. Now every memory block has a reference count mechanism, which indicates how many pointers are pointing to that memory block, or how many pointers are the owner of the memory block. Now that's called reference count. Here we say it's retain count. The variable used to denote that value is retain count, which is declared in NS object. So reference count, when it gets 0, that particular memory block gets deallocated. Okay, so when you write alloc, the memory block gets allocated, and a retain count, which say is unassigned to the 1. Now when you say assign, and when you equate the pointers, the pointer points to that memory block without incrementing the reference count. So it's a shallow copy without incrementing the retain count. This is a phenomena used in C++, where memory block is shallow copy do not increment the memory retain count. So if any pointer goes out or it removes itself from the memory, it will reduce the retain count by 1, and once the retain count becomes 0, your block of the memory is out, and that's why you get a lot of null point exception. Now this is all called assign behavior. If you have retained, then there's a special function which gets called retain before assignment, which is declared. It doesn't do anything special. It just increment the reference count by 1, so that when a name points to that block, it already has incremented value, so it becomes retained. So even though some other pointer which pointing to the memory block removes itself from the memory and it will decrement the retain count by 1, your name variable is still will be pointing to the memory block because retain count is not reduced to 0. So this is called retain. The Java programming standard use retain as by default. So whenever you equate two pointers, it's a shallow copy with the increment in the retain count. So a lot of Java developers feel relaxed, because they don't have to manage that retain count management, because it's shallow copy with retain. Now when you say copy, the copy is called before equating. Now copy is something like a deep copy. The entire snapshot of the block of memory gets created into the location, and the name is pointing to that particular location. So if the retain count of ABC reference was 100, the retain count of name which pointing to the new memory block will be 1. So a copy is nothing but a sophisticated way of writing alloc init with object. Okay. Now copy is not applicable for all type of object. It's mostly applicable for Objective-C collection type like string, array, dictionary, set, or an object which conforms the NS copy protocol. So now you have understood how it happens. The C++ runs on assign behavior. The Java runs on the retain behavior, whereas Objective-C again runs on the C behavior called assign. So you have understood the difference between the assign, retain, and the copy. Assign is a shallow copy without incrementing the reference count. Retain is a shallow copy with incrementing the retain count. Copy is a deep copy. Now the golden rule says what? Which one needs to be used at what, right? Now suppose you declare your property as assign. Now in vehicle.h, if your name is declared as assign, then you have to make sure. So in order to understand attributes properly, you have to understand encapsulation. What do you mean by encapsulation? Encapsulation means says what the object says. A vehicle object will say, I am the one of the owner of the name. I don't mind anyone else pointing to the name content, but I am the one of the owner. If I go out, I will remove my ownership, but no one else should control my ownership. Now that's called encapsulation. So if vehicle.m, inside your vehicle.m, you write explicitly alloc, that means you have already took the ownership explicitly. In that case, you will say assign. So we declare assign as an attribute only when we explicitly allocate the memory using alloc in the same .m file. So we declare assign as an attribute in the .h file only when we explicitly allocate, or say call alloc using allocate the memory using alloc in the same .m file. If some other class creates the reference or allocate the memory, that means, in other words, someone else is the provider. In that case, we use retain. Now, for collection type of objects like NSString, NSArray and others, copy is also an option. So if you have UI image, it's a non-collection. You will say directly retain because if you're not allocating in your .m. But if it's copy, now for copy, you have 3 scenarios. Out of these 3 scenarios, only in one scenario you will be using copy. Rest other 2 you will be using retain. Now, suppose you have a name. The provider class, if provider is non-mutable, means it's not changing its value, it's a fix, we will use retain instead of copy. Now, if I use copy, I'm calling an allocator, which is a memory instance or the performance instance system. If I know the provider is not changing its value, why should I call alloc? I'll just say shallow copy retain. It will be much faster, right? 3.2 says if provider is mutable and you want to mutate with that value, with the provider with the value, you will use retain. And suppose you have a contacts app. When you see the list of the contact, you click the detail of the contacts open. When you edit, when you come back on the same screen, you see the name gets reflected. In that case, you pass the retain reference, right? So you want to mutate along with the provider. You want to change your value with your provider. So why should I call copy and then make it also mutable? I'll say 3.3, if provider is mutable and you do not want to mutate, you want to snapshot, you will use copy. So in only one scenario we use copy, when the provider is a mutable and you do not want to mute. So I hope these golden rules are very clear. As we go on with the practical exercise, these all golden rules will be used, and that time you will come to know how to use them. Now, the other set of property we say is third, atomic or non-atomic. It's like thread safe, unsafe. Now, by default it's atomic. As we know, it's a UI related application development. Your UI should not get a single second of glitch. UI is always run in the main thread. So any property which will be assigned to the UI related variable in your application, it should be non-atomic. Means anytime any 2 threads can attack your getters and setters simultaneously. So it's called non-atomic. But if your property is not at all related to the UI component, it's purely for a database and it won't be exposed to the UI, then we're going to say atomic. Means synchronized access to the. So make sure whenever your property is gonna relate to the UI, make it non-atomic so that your UI will never, your main thread is never get in a queue to access that getters and setters. Okay. Now, before we go move ahead, the memory management out here is very simple. I'm gonna list you some few methods because of which the retain count increases. You have to follow the opposite when scope and purpose over. So whenever you create an object, you should know the scope, whether it's a global, local, and its purpose. When both scope and purpose gets over, you have to make sure you remove the object from the memory. Now the list of methods I will show you. Now these are list of methods which increase the retain count. You have to follow to reduce the. When you call alloc in your function, you call release. When it's retain, you call release, copy, release, Add object, whenever you call, you want to call remove object and index or remove all object. Add subview, opposite remove from superview. Push view control, pop view controller, present model view controller, dismiss model view controller, set object for key, remove object for key. So you just have to make sure if your line of code is calling this method, you are responsible for incrementing the retain count by yourself. This methods very clearly. So there's a class which contains an object. We have declared UI background in a .h of some class. It has, say, load background method and one more method. Now in load background, we are creating the UI image using alloc. So retain count of temp img will be 1. The retain count of UI image view at this line will be background will be 1. Add subview will increment the retain count to 2. So now if you see UI image temp img scope is within this method, and after the purpose was to give the image to the image view. So scope purpose is getting over. So you're gonna say temp img release. Now let's analyze what we have written with respect to retain count. Temp has been created by calling alloc, so that at the end of the first line the temp img retain count will be 1. In second line, calling alloc on a background will result in a creation of background and its retain count will set up to 1. But during the calling of the constructor init with image, the past reference UI image in our case is temp image is also assigned to the image property of UI image view, that is a background. The image property is a retain, so that temp image is retained before the assigning to the image of the background. Thus at the end of the second line, the retain count of temp img will be 2. In third line, we are adding the background to the self.view, which will increase the retain count of background to 2. So as per the rule, when scope and purpose of the object is over, we call opposite of that method, which increased the retain count. So in above, there are two objects, temp img and background, both having the retain count 2. Now let's take one by one. First we will take temp image. Alloc statement purpose to get the image property of the background set. Thus purpose is over. The scope of this variable, that is temp img, is over as it's a local variable. Thus we will be called release at the end of the method. Whereas background scope is global to the class and its purpose is not yet over. Thus we are not calling any message to reduce the retain count. Thus after this method, the following retain count scenario exists. Temp image retain count is 1. Background retain count is 1. Now even though this was locally created, but being assigned to the background view, its memory block is still existing in your memory. So first the retain ownership was taken by the class, say ABC. Then the new owner was added, UI image view. After this function, the class ABC says I don't want the ownership with the temp img. It releases them. So there is only one owner left with the temp img block. It's called UI image. Now after some time you have called a background. So it says background remove from superview, add subview, opposite remove from superview, background release, and whenever retain count is reduced to 0, we make it the reference nil. So after execution of this, the retain count of background will be 0. Thus the dalloc of UI image view will get called. Inside the dalloc of UI image view, image property which will be released because retain opposite is released. So in UI image view, if the attribute is called retain on the image property, that retain opposite release needs to be returned somewhere, obviously at the dalloc level, thus making the retain count of UI image object set to 0, and in turn the result into deallocation of UI image object as well. Now let's see now we'll be seeing one more one of the most important concept called AutoRelease. Now I've created UI image with this line. Let's investigate these two lines, UI image, and in another scenario we create UI image using. Now what is the difference between these two lines of code? Are there different types of images or are they same? Now let's reduce the font size to 18 so that now both of them create UI image only. They are both a UI image, but one is using alloc explicitly by you calling alloc, other without calling an alloc. Obviously it's a class method which returns the UI image. Now when you call an object or an object gets created explicitly by calling alloc, new or copy, you say that those objects are non-auto-release objects. Means you have to take care of releasing them. If the objects are getting created without alloc, apart from alloc, copy and new, you say they are auto-release objects. Now those auto-release objects are released by the system automatically. So you will say it's always better to use the auto-release scenarios only. No, an application is not memory optimized if you use only the auto-release object. The application is not optimized if you use non-auto-release objects. So it's a combination of both will lead to the creating a good memory optimized object. Now let's see the scenario. The first scenario says all global objects should be auto-released so that they are remaining always, they're cached, right? So you don't have to create an object again and again. You can use the same reference. All singleton objects should be auto-released. The singleton object means only one object remains in the memory. Okay. Now, the third and the fourth scenario are more subjective. Now consider a UI label. Okay, a UI label has a background color property which is of type UI color. Now UI color is retained. Now suppose I create a label 1 and I set the label 1 background color as clear color, the transparent color. So the RGBA value of say color C1 is 110. Now I have say 10,000 UI label object created in my application, and all 10,000 UI label object has same background color like transparent color. If I use alloc, I am creating 10,000 color object in a memory which has the same content R1, G1, B1, alpha 0. What would be the best scenario? Creating a one content and one container and having 10,000 pointer pointing to it. That's called more optimized scenario. So when an object will be used massively throughout the app, we make that object auto release. UI color, clear color. The fourth scenario, suppose you have an object which is animating with the 6 frames in one screen, say Halloween pumpkin. Now suppose you have 100 of Halloween pumpkin coming into a screen at one time and all of them having the same set of animation frames. So a pumpkin object will have one UI image view object, one NS array, and that NS array will contain 6 UI image objects. Now if you use alloc of UI image, you are creating 6 into 100, 600 UI image objects in your memory. Again, it's massive. The best part would be creating the 6 images using image name will lead to create only 6 containers in the memory without creating 600 containers, and each container will have its own reference, number of reference. In that case, we use auto release. So when same type of objects arrives in memory in huge quantity, we use auto release. And fifth one will demonstrate in this document. Okay. Now see, let's see without using the alloc method. So here it is. So this is called auto release. When you say an auto release object, they are delayedly released. So if you see temp image scope ends here, right? But because it's being auto released, it will release after few lines, even though after the scope ends. So auto release objects are called delayed release. So before they release, if someone else takes the reference by calling the same method, the other person takes the ownership. So this is how the caching mechanism happens. So that's what we have shown you. When you create this huge number of items in the entire project, we use this objects. Okay. Now the last one is consider the following method which returns the concatenating of username and first name. So I have a string which concatenate full name with first name, last name. It creates a string using alloc and returns the temp. As per the memory management rule which we have defined, alloc opposite release should be called once the method ends. If we call release, however, the string that is temp_str will be deallocated before it returns, and thus method will always return the invalid object. Using auto release will signify that you want to release ownership, but you allow the caller of the method to use the return string before it's deallocated. Thus, auto release object will be released delayed. So when you make in this scenario, so whenever an object getting created local to the method and that same object needs to be returned by that method, we make sure that needs to be auto release. So when you make it auto release, it will be delayed release. So the calling method, the class which we gonna call this will take the ownership of this reference, and eventually after some time the being an auto release, it will remove. So what happens if you call alloc and you want to give the ownership, you can always call the auto release explicitly, or you can use another method if you have which returns the auto release object. So you can have something like this, string with format. So here it's auto release by default. So certain times we don't have the option, we have to go with alloc. In that case we explicitly call auto release. So this is how. So we have following tips for managing memory. One should try to create UI components when they are required and remove when they are not reusable. So one of the UI component, whenever you create, you take the ownership and remove when you are not needed. One should load view component inside the view will appear, and so these are something golden rules which we have. Okay, so you can see this document. Okay, so this is what is all basically about the auto release and non-auto release. Now with Xcode 5, now we are seeing something. Okay, so we have done with the properties. So we saw what are the attributes of the property, then we saw how auto release object helps you to create. So we saw the auto release concept, when to use. These are 4 scenarios, and the 5th one we demonstrated like a function call. So if a function is returning some value and that same reference getting initialized internally to the same function, that reference needs to be auto release. Now auto release means delayed release. Okay, now next thing, it's again a memory management before we move to a new topic called ARC, automatic reference counting. So in next exercise we'll see what is ARC, what is automatic reference counting, when to use, how to use it, and then we'll move to the new Objective-C topic.